Welcome back to Mrs. Cox's math class, and today we're going to be working with the 8th graders on their beginning of the year review day 6. So this lesson is focusing on supplementary angles, complementary angles, looking at parallel lines with transversals, and all of those corresponding angles that of course they probably completely forgot. So they'll have a lot of notes in their video. And again, these notes are going to be at the beginning of the year. My hope is that they'll utilize these notes a lot as we go on and continue to do math again this year. So I'll share my screen and I'll show you the Get More Math there. So here's the Get More Math teachers program, and here is my 8th grade file folder. And I come up here to the beginning of the year, and this is review day number 6. And so there's 7 different skills here. They only have to get 1 point for each one. And let me go ahead and assign that. Now, for some of the students, if they remember this from last year, they're going to do really, really well. But what I've just found over the years is that this is a tough one for them to remember. And so taking good notes is really helpful. So the first one is just looking at complementary and supplementary angles. This is skill 1110102. This one, now notice that this one here had algebraic expressions for each of the angle measures. This one here does not, so this is easier. This is skill code 1110104. This next one is looking at parallel lines with a transversal. This is skill code 1120001. This is going to be supplementary angles, skill 1110101. This one's going to be talking about vertical angles and 1110108. The next one again is parallel lines with transversals. Now these are expressions, so a little bit harder. 1120014. And the last one is complementary angles with expressions, 1110105. And so that's going to be the focus for today as we take a look at all of those angle relationships that we learned in 7th grade that I want them to be really good at here this year. And now you'll see the lesson as I actually taught it to the students. Well, hi. So today we are doing beginning of the year review lesson number 6. Let me share my screen, and we'll get started with it right away. So what we're working on is we're going back and we're looking at angles, right? So we're going to be looking at supplementary angles, complementary angles, vertical angles, and alternate interior angles. So we're going to go back to those ideas, okay? So supplementary angles are angles that have a combined measure of 180 degrees. So if we take a line right here, and we just have 2 angles. So we have angle A and angle B. They're going to add up to 180 degrees. Complementary angles are angles that have a combined measure of 90 degrees. And so when you see these, you will see the right angle mark. And that'll let you know if these are 90 combined measures 90 degrees. Vertical angles are angles created when 2 lines intersect. So if we have 2 lines that intersect, so we've got this line here, and then we have this line here. And when they intersect, they create vertical angles. And vertical angles have the same measure. So we know that this angle and this angle have the same measure. And that this other set of angles here too. So this angle and this angle also have the same measure, okay? So we know that these 2 measures are the same and these 2 measures are the same. And then we have alternate interior angles, and this happens when we have parallel lines. So we'll create a set of parallel lines. Parallel lines are 2 lines that run side by side and never intersect. And we use this mark to show that they are parallel. So we see that these are parallel. And then we have another line that actually intersects them. And the line that intersects them is called a transversal. And so as we have this line that intersects 2 parallel lines, it creates some interesting dynamics. So alternate interior angles have the same measure. So I know that this angle and this angle have the same measure. And I know that this measure and this measure have the same measure. And then of course I know that these are vertical angles, so I know that this one is the same as this one. And so they have this relationship. We want to make sure you understand it. Of course, these 2 are vertical angles because, again, it's 2 lines intersect to create vertical angles. When we have two parallel lines with a transversal intersecting them, then we have the alternate interior angles that have the same measure. So I know this angle, this angle, this angle, and this angle are all four the same. And this one, and this one, this one, and this one, again, are all four the same. So at this point, you're going to probably need to stop and stop your videotape. Make sure that you have all of these in your notes, okay? And of course, you'll probably want to just stop right here and make sure you get all these written in your notes, and then we'll go on, okay? The first one, pretty easy, find the measure of the missing angle. Well, we see that these angles share a line, so their measure is 180 degrees. So what we can do is we can mark that as angle X, and we can just say that X plus 106 is equal to 180. And then we'll just want to get X by itself. So we'll add a negative 106 to both sides. Those are opposites. So we end up with X is equal to, and then here we'll have to borrow, and X is equal to 74 degrees. So we know this measure is 74 degrees. With Get More Math, you just have to type in the number 74. So now it gets a little more complicated. These two angles share a line, they're supplementary. And so I know that when I add these two together, they're going to equal 180 degrees. And I want to show you a quicker way to add these together. So we have 3t plus 148 and 5t plus 104 equals 180. So what I'm going to do is I'm going to add these vertically, which makes it a little bit easier than having a long string horizontally. So 8 plus 4 is 12, carry down the 2, carry the 1, 4 plus 1 is 5, and 1 plus 1 is 2, and then 3t plus 5t is 8t. And then I want to get rid of, get all my variables on one side, my constants on the other. So I know this number is going to be larger, so I'm going to go ahead and write it up here because I know I'm going to be subtracting. So I have a positive and a negative. And then those are opposites, so their sum is 0. So I get 8t is equal to, and then I'm going to go ahead and this will be negative because the larger number is negative, and 2 minus 0 is 2, and then I borrow, 15 minus 8 is 7. I'll divide both sides by 8, and I get that t is equal to negative 9. Now they want to know the angle of RBD. So RBD, this is the one they're looking for. So now that I know what t is, I'm going to substitute in here, and then I'm going to solve. So I'm going to have 5 times negative 9 plus 104. And 5 times negative 9 is negative 45. And then I have a positive and a negative, so I know I'm just going to subtract here and keep the sign of the larger absolute value, which is positive. So I know my answer is going to be positive, and this is going to be a 9, and this is going to be a 5. So that I know that this measure right here is 59 degrees. And again, you just type in 59 for Get More Math. The next one, they want us to find the measure. Now these are complementary angles. Complementary angles have a measure of, combined measure of 90 degrees. So we get X plus 36 equals 90. I want to get X by itself, so I'm going to add a negative 36 to both sides of the equation. And of course, these are opposites, so sum is 0. So I get X is equal to, and then 10 minus 6 is 4, 8 minus 3 is 5, so that this measure is 53 degrees. This one here, again, same thing. We're looking for measure PMB. So PMB, this is the one we're actually looking for. So once we get it solved, and I'm going to do the same thing I did in the last problem. So I'm going to say 8C plus negative 34 and 3C plus 25 is equal to 90. And then I get 9C plus, and these are positive and a negative, so I'm going to subtract, keep the sign of the larger absolute value, and the negative's larger, so I have to borrow, and 14 minus 5 is 9. Then to get the C by itself, I'm going to add a positive 9 to both sides. These are opposites, or sum is 0. So I get 9C is equal to 99. And then I divide both sides by 9. And I get C is equal to 11. And then I'm going to substitute it in here. So I get 3 times 11 plus 25. 3 times 11 is 33 plus 25. 3 plus 5 is 8. 3 plus 2 is 5. So this measure is 58 degrees. Now the next one shows two parallel lines, and here's the parallel line marker. So I want to make sure you understand that when you see that, that's what this mark means. It means these two lines are parallel, and then there's a line intersecting them. And so we know that this is a transversal, and so we're going to have alternate interior angles are the same. So they want the measure of angle 7, and I know 7 is the same as 6. And now that I have 6 here, I can see that 6 is the same as 112. So your answer is 112 degrees. Okay, so again, that's alternate interior angles have the same measure. The next one, they want the measure of FHC. FHC is this one right here, so this is what we're looking for. And we know that these are two lines that intersect. They create vertical angles, and we know vertical angles have the same measure. So I know that 6P plus 162 is equal to 4P plus 158. And so we know that they have the same measure, so they're equal to each other. So we're just going to go straight to step 1 is get rid of subtraction. There isn't any. Step number 2, solve distributive property. There's no distributive property. Step number 3, combine like terms. Nothing to combine here, nothing to combine here. Step number 4, get your variables on one side, your constants on the other. So what we're going to do is we're going to move the smaller one since they're both positive. So I'm going to move the smaller one by adding its opposite. So it's a negative 4p. And of course, these are opposites. Their sum is 0. So I end up with 158 is equal to, and then I have 162. And then I have 6p minus 4p is 2p. And again, I want to get the, on one side, constants on the other. So I got all the variables over here. So this constant's got to go. And this one's negative and this one's positive. So I know I'm going to be subtracting. So I'm going to put the larger number on top. And these two are opposites. Their sum is 0. So I end up with 2p is equal to, and then I know the answer is going to be negative because the larger absolute value is negative. And then I'm just going to do the math. So I have to borrow, and I end up with 12 minus 8, which is 4. I divide both sides by 2 so that p is equal to negative 2. Now I'm not looking for p. What we're actually looking for is this measure right here. So we have to now substitute. So we'll do 6 times negative 2 plus 162. And we 6 times negative 2 is negative 12. And so we're just going to subtract that. 2 minus 2 is 0. 6 minus 1 is 5. And 1 minus 0 is 1. So this is 150 degrees. So it's just doing all those steps one at a time. And here's the last one. Again, we have parallel lines. So here's the mark right here that shows that they're parallel. And then we have a line that that cuts across both, intersects them both. So that's called a transversal. And they want to find the measure of angle 6. So this is the one we're looking for. So we're going to start with what we know. Well, I know that this angle and this angle are the same. And I know that these are alternate interior angles. And so this is the same as well. So when I solve for one of these, it's going to be the same as angle 6. So I just go ahead and I make these equal to each other. So I get x plus 100 is equal to 7x plus 202. So the first thing I always want to do is step number 1 is get rid of subtraction by adding its opposite, and there isn't any. Step number 2, solve distributive property. There isn't any. Step number 3, combine like terms. Well, there's nothing over here to combine, and there's nothing over here to combine. So step number 4, get all your variables on one side of the equation, all your constants on the other. And I see I have a variable on both sides. And what I want to do is I want to move the smaller one since they're both positive. And that way my variable stays positive. I just make fewer mistakes when I do that. Those are opposites. Their sum is 0. So we end up with 100 is equal to 6x plus 202. And again, we're still working on step number 4. We've got the variables on one side, but we've got to get those constants over here. So we'll add its opposite. Well, the opposite of 202 is negative 202, which is going to give us a positive and a negative. So I'm going to put the larger number on top so I can do the standard subtraction. And I end up with 6x is equal to, and then I just subtract. I know my answer is going to be negative. 2 minus 0 is 2. 0 minus 0 is 0. 2 minus 0 is 1. And then I just want to divide both sides by 6. And a positive divided by a negative is negative. And 6 goes into 10 one time with 4 left over. And 6 goes into 42 7 times. So we end up with x is negative 17. So it doesn't matter which one you put this back into because they're both the same. This equation actually looks easier to solve. So I'm going to put it in here. So I'm going to substitute negative 17 plus 100. Well, one's positive, one's negative. So I'm just going to subtract 17 from 100. And I'll have to borrow. 10 minus 7 is 3. 9 minus 1 is 8. And I know that the measure of angle 6 is 83 degrees. And so that's the end of this lesson. So that's what you're going to be focusing on today. And we'll work on the even ones in class tomorrow. Okay? All right, you guys. Thank you. And I'll see you in the morning. Okay. Bye. And that is the end of this lesson in Mrs. Cox's classroom. If you are enjoying my videos, please like and subscribe. Thank you.